Okay, so the next main topic in programming is iteration. But before we get on to that, a quick word about IDEs. Now, IDE is short for an Integrated Development Environment. And what you see here is it's not really what I'd call an IDE. It's an online compiler. And you've got different windows here where you can type in code, you can see output, and on the left you have the folder for the project where you currently just have a CS file, which is your source file, the code in other words, and then the executable file, the exe, which is the object file it's called. So source files and object files. You can actually see what's inside the executable if you click on it. A little warning tell you it can't be run in DOS mode, and these symbols are binary. The strings you'll find in there for different symbols. This is what it generates when you click run, and that's what it actually runs and lets you see the output over here. Remember that for a second because we're going to close down Replit and use Visual Studio instead. Now I'm using Visual Studio 2015 and it's Community Edition. You can get Pro Edition from the new version of Microsoft DreamSpark, which is called Imagine Academy, I believe. You can get the Pro version off of there, which has got some nice tools for doing diagrams and so on. But other than that, the Community Edition is just fine. And it's completely free. You don't even need a DreamSpark account. Sorry, Imagine account. So Visual Studio is the name of the IDE, the development environment. And what's integrated about it? Well, it combines a whole bunch of tools and also integrates, well, some of those tools are the compilers for different languages. So you can install Visual Studio with various different languages. So there is a thing called Visual C Sharp, there's Visual Basic, there's Visual C++. They're all just different facets, really, of Visual Studio. But Visual Studio is not C++, it's not C Sharp, it just allows you to write code in those languages. So, first thing we should do in Visual Studio is create a new project, which you do from the File menu, then New Project. And you get a dialog that pops up with all the templates. And if we go to Visual C Sharp, there's all kinds of different templates here. I'm going to click on Console Application. That's what I'm going to make. It's quite similar to what we've been doing, but it's going to actually create a console window. Now, console, I don't mean like a PS4 console. That is a text console. Now, you should choose a location if you haven't set it up already, particularly if you're doing this in a college where it tries to save to some sort of network area. You may not want that. Also give it a name. So for this one, I guess we could call it Session 3. You can opt to create a new Git repository here. I'm not particularly keen on the Git add-on for Visual Studio, but that definitely is a possibility. I strongly recommend that you check up and learn about Git at some point. It's used so widely in industry, it's really handy. It's a source control method. It lets you keep different versions and branches of your code, but it's definitely not for now. Okay, so let's click the OK button. It will generate our project. And kind of like how, if I can just switch back to Replit for now, you've got your source code in one panel and you've got all the different files in your solution on the left. It's not that different in Visual Studio. You've got your source files in tabs along the side here. And on the right, you've got your Solution Explorer. And this is structured in hierarchical fashion. So you've got your program.cs file. That's your code file, your source file. You can actually click this little arrow to see what's inside it, and it shows you all the classes. Now, there is only one class in here called class program. And inside that, there's only one function, one method called main. So it shows you the structure right here of all your objects in your code. But it also shows you all the references to different libraries that it has, property settings, and any other files that it may require. That's not necessarily, by the way, all of those are not necessarily linking to a file that's in that particular location on the hard disk. If you right click on this, you can, where is it now? You can view the properties and see the full path for that file if it's a file on the disk. But some of them are not files on the disk, so you won't see that in here. So not everything in the Solution Explorer is a file that you would find on the disk. But having said that, you can find all these files on the disk. I'm going to copy and paste this path here into a file explorer window. Take out the actual file name so we can just see the session 3 folder. Now you'll see that it's got two folders with the same name. So that the first folder contains just this .sln file. That's short for solution. You didn't see that in Replit. In Visual Studio, the solution file is just a bit of text. If you open it up in a text editor like Notepad or Sublime Text, you can actually see what's going on here. It's what version of Visual Studio it is and all this kind of stuff. I wouldn't worry about that right now, but the key thing is there's no code in here. So you can't run a solution file on its own. The solution file just links together all the bits that it needs. Here we are. You can see that a lot of this stuff is stuff that you do see in your Solution Explorer, but not all of it's there. And there's some things here that aren't there. So this is not a one-to-one mapping of files on the disk. That's what I'm getting at. However, it does have a specific place on the disk. So what you must try to avoid doing is clicking File, Save As. Because then what you're doing is you're picking another folder for it to go in. The original is still there though, and that's the one that it's using in the solution file. So all the code changes you've made are being saved somewhere else, not part of your project. So save as is usually bad unless you're sure you know that's exactly what you want to do. I would suggest to save all. In fact, to be honest, I almost never click save because every time you hit start, the first thing it has to do is compile all your code, and it can't do that unless it saves it all first. So the worst case scenario, you'll lose any work. If it crashes, you'll lose only work that's happened since you last clicked the start button. If you don't click start very often, then save all is your best bet. Okay, but you may also notice there's some other things in here. So in Replit, it did have using commands, but there wasn't quite so many. Notice these are all kind of grayed out. It's because we're not actually using them yet. If we put in things in here, like for instance, console.writeLine, it recognizes that that's using the system. So now that's turned dark. You could probably take some of these out because I'm not going to be using link or text or any of that sort of stuff in this example. I'll leave using system in for the console. The other thing that's new is this thing called a namespace. What is a namespace? Because some people get confused by it, but it's actually dead simple. It's just a space with a name. And that name in this case is session 3. And the curly brackets associated with it, notice by the way that Visual Studio highlights matching brackets. I think REPL did that as well. So everything inside those curly brackets, and remember you can collapse it as well, is inside the same namespace. And things that are inside the same namespace are always in scope. They can always see each other, even if they're private. It means they're private to that namespace, if that's the case. So that's all a namespace is. And in fact, if you write some other code somewhere else, you would be able to see this program if you put in using session 3. That's all using does is it says, see this namespace here? Pretend that we're in that same namespace so we can access the stuff in it. That's what's happening there. Okay, so why did we switch to Visual Studio? Well, Visual Studio has a ton of extra tools. Some of them are really powerful. There's debugging tools. There's something called IntelliSense, which is like autocomplete on steroids. There's tools to rename variables really easily, refactoring tools, bookmarks, highlighting, context-sensitive highlighting, and all that kind of stuff. So there's a reason it's the leading IDE on the market right now. It's got a lot of really good tools in it for developers. So the main one, in fact, you've kind of already seen it pop up, is IntelliSense. I start typing in console. After a couple of letters, it's figured out that's probably what I'm going to go to. And you can press tab or enter, or I think space works as well. Yep, and it'll complete it for you. The red squiggle, I think that is its technical name, is the red squiggle. That shows you there's an error. If you point at a red squiggle, you will get a pop-up saying what the error is. Don't worry about that in this case, though. It just that error is happening because we haven't finished typing. When you hit the dot, the reference operator, in other words, it shows you all the things you can refer to inside the console. This is something that I don't think Replit had, where you can scroll through or use the arrow keys to move around and see what's in here. It just gives you a nice way to explore the structure of the various objects in your code. For instance, you can change the title of the console. You can do WriteLine and all that sort of stuff. Okay, so let's do WriteLine. And again, oh, by the way, sorry, I should have mentioned, In that pop-up, you'll see little icons on the left. Those icons do tell you what these things are. That little cube means it's code, it's a function. These sort of spanner icons mean that it's a property. Which a property is basically like a variable. You can think of it as a variable for now. And there's also events and other things. There's an event there with a little lightning symbol and other things in there. Okay, so when we open the brackets, IntelliSense pops up again, and it's telling us how you can use the WriteLine command and what it does. It gets that information from some XML, which maybe we'll get around to showing you how to do that later on. But it also shows us that there are 19 versions, 19 what's called overloads, 19 overloaded versions of the WriteLine command. One of them is a blank line, and it shows that that's a void function with no input parameters inside the brackets. But if you put something in the brackets, you can use a Boolean value, a character value, an array of characters, a decimal, blah, blah, blah. There's 19 different options in there. So it's a very versatile function, and those arrows lets it show us all the different ways you can use it. Don't forget the Terminator. I'll be back. Okay, so IntelliSense is one of the most powerful tools. Please use it over and over again. It's so handy to be able to browse through and make sure you've got the right capitalization and stuff. It will reduce errors. Okay. So yes, so we're looking at iteration, also called loops or repetition. Just make sure I spelled that right. There is a subtle difference between those names though. A repetition implies that you're repeating something you've done already, whereas an iteration can also include the first loop through. So you can iterate something and then reiterate it. But when you do something the first time, every time you do it again, it's the repetition. So iteration is a more accurate term for programming in most cases. So what ways can we do iteration? Well, there's two main approaches called test before and test after. So I'm going to start with test after, and a loop which does a test after basically is like this. You tell it what to do, that's the key word there is do, and then you put some command in. I can make it a console.WriteLine, I suppose. So that's what you do over and over. But then you have to tell it. I think if I try and run just now, I can click start, or by the way, F5 does the same job, tries to compile it. It says there's build errors. Now when you get this pop-up, by the way, would you like to continue and run the last successful build? I would strongly recommend that you never click yes to that, because what that's going to run is not your code. It's going to run the last version of your code that was working, which is explicitly not this version, because this one's not working. That's why you're getting the message in the first place. So every time you click yes, you're running some old version of your code, which is very rarely useful in my opinion. So I always click no to that. There's a squiggle. Syntax error, while expected. Or in fact, if you have an error list at the bottom here, I kind of cunningly closed that so you didn't see it until we needed to. The error list in here will show you the same things, while expected. Because the structure for do loop is do while. So you keep on doing this. This is the sort of payload. This is the body of the loop, as it's called. So the body of the loop keeps repeating as long as some sort of condition is true. So it keeps doing this while our condition is true. What's the condition? Well, it's some kind of Boolean, just like the condition in an if statement. So we could put true in there. But as you can imagine, just like with if statements, directly putting true or false in here is not particularly useful. But do while true is not that bad, because what it means is it's going to repeat that loop forever, because true is always true, and it keeps doing this while our condition is true, so it's going to do that forever. Let's run it, and you'll see. Sorry, I pressed F5 there, but I probably should have went to the start button. You know what? Probably would have helped if we could see it doing something. Let's just make it right rather than WriteLine, and we'll write the letter A to the screen. There it goes. You can even see it scrolling through. So that's a do forever loop. You have some body inside a do while. If we were to make that false, excuse me, that's much less useful, because the false condition means that the while is never going to trigger, and it will only run this once and then quit. fact, if I hit start, it will flash up. You probably didn't catch it, but there was a letter A on the screen there, just one, and then it ended. If you don't believe me, let's do a read key at the end. And incidentally, that's one of the reasons why I switched to Visual Studio just now, because read key doesn't always work as intended in Replit. There we are, one letter A, waiting for us to press a key, and we're done. So do while false, very, very unlikely to be useful. The only time you might do that is when you want to debug stuff. Do while true is useful in the sense that you can make this loop forever. But notice there, oh, hang on, that's turned green. A green squiggle is not an error. A green squiggle is a warning. Unreachable code detected. What that means is it's figured out that this line is never going to run because it's always going to be in this loop. It's smart enough to know these things. So that code cannot ever be reached. It's unreachable. There's no point it being there. It's just giving us that warning. But you can run with warnings in your code. You can't run with errors, but you can run with warnings because the warnings are just there letting you know something might be wrong. I mean, there is an old joke about programmers where they say that programmers would drive off a bridge that's out because they ignore warnings. It's very often what we do. Programmer humor, don't you love it? So that's a do while loop. And just like inside an if statement, the body can be expanded by putting it inside curly brackets. And for the moment, for beginner programmers, I would recommend you do that all the time, just until you get used to it. So a do while loop in C# always starts with the word do, and don't ever put anything after the do, because anything you put in here, it will be considered to be the loop body. And then it's going to complain saying it expects the word while, which it doesn't get until much later. So realistically, you should never put anything after do except the curly bracket. And then after the closing curly bracket, you must always put the word while, never put anything else in between, because you'll get the same error. While expected. Yeah, while expected. So it always looks like this. Do, curly bracket, and then after the closing curly bracket, while, brackets, some kind of condition. Okay, let's make it actually do something. So it's going to keep on saying to us, type quit to exit. And the condition, it's going to keep on doing that as long as we read something from the keyboard and the thing that we read is not equal to, remember the exclamation mark means not, so the thing we read from the keyboard was not the word quit. Oh, helps if I can type. So it's going to keep repeating this as long as we type in something that is not the word quit. As soon as we do type in the word quit, that condition will be false, and we'll continue processing. I'll put a read key in here just so you can not see it crash. So type quit to exit. No. Quit does exit. Right. Now here's where I'll show you one of the other powerful tools in Visual Studio. It is the debug tool. So in the debug menu, there's the F5 key I've been pressing to start debugging. That's exactly the same as that button there. But you can also step into and step over. I'm going to ignore step over for now though. Step into, or the F11 key, runs the program, but then it immediately pauses it in debug mode. And when you're in debug mode, you see this yellow line. You should be able to switch back to see what's currently viewable on the screen, but there's nothing there right now. Press F11 again, or I think that's it. Yeah, there's step into, or debug, step into, or F11. It'll take you to the next line. So it doesn't actually execute the do command. The only line it executes is the beginning of the loop. But there's still nothing happening. Next line, console.writeLine, type quit to exit. Doesn't show it yet, because what the yellow line indicates is the line that's about to run. It hasn't ran yet. If I press F11, it runs it. You can now see that output. It's moved on to the next line, which is just a closing curly bracket, so it's not going to do anything. But after that, it then checks the condition, and the condition includes a read line. So as soon as I press F11, it's going to wait for me to type something in. There we go. Quit. In fact, no, let's type something else first. So what I typed was not equal to quit, so the condition was true, and it looped back around. Console.writeLine. we go, have a second one. And then it's going to wait for me to type something in again. Let's quit this time. And that negated that condition, so it moved out of the loop and continued. On to read key, waits for us to press a key, and then exits. So that's the debug tool, another extremely useful tool in debugging your fault finding your programs. Okay, let's do a bit more practice then. So I'm going to do a sort of improvement on the coin flipping algorithm. So we're going to count how many times we get heads and how many tries it took to get 10 of them in a row. We'll have a random number generator, and let's seed it. And now here comes our do loop. And the do loop is going to keep on going while the number of heads we have is less than 10. So it's only going to exit the loop once the number of heads we've flipped reaches 10, because that will then be false. At the start of the game, heads is 0. 0 is less than 10, that will be true, and it will keep on looping. Eventually, when that reaches 10, heads is less than 10 will be false, and it will continue on the next line. So the next line will say how many tries it took. Now we could do concatenation like that. Oops. But just for a bit of variety, I'm going to do it a slightly different way. If you put inside a string curly brackets and a number, that number then corresponds to another parameter. If this is too confusing for you, go back to the way you just saw a minute ago, but there are good reasons why you might want to use this approach in future. So, not least of which is you can then store these in some sort of string reference table, but that is for more advanced techniques, so you don't necessarily need to do that just yet. Okay, so keep on doing something until the number of heads you've got is no longer less than 10, and then tell us how many tries it took and end the game. So what's our main body? Well, what we're going to do is flipping a coin. Every time we flip a coin, it's going to say so. And if that coin, which you represent as a random number, either 0 or a 1, so if you get the next random number less than 2, it's either going to be a 0 or a 1. Let's say a 0 is a heads and a 1 is a tails. So if that random number is a 0, then our number of heads should increase. Heads equals heads plus 1. Or if you remember, we can shorten that to heads plus equals 1. Or even just plus plus. And that can either be inside curly brackets or not, because it's just one line of code. I'll leave that up to you to decide. Some people like those brackets to be in just for consistency. So that's the number of heads have went up, but also the number of tries should go up. We've taken another try, whether we got ahead or not. So each repetition of the loop, each iteration of the loop flips a coin, and if it gets ahead, then it counts it, and whether it gets ahead or not, it counts that try. And once we reach 10, we should have a number of how many tries it took, and we're going to just say that on the screen. Does that all make sense? Let's try it and see. It took 15 tries to get 10 heads, is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah. 15 flips, we got 10 heads out of that list. Just a simple example of a do loop doing something, not very useful, but should explain the idea to you. But there is another option as well. This is a test after, because our condition is tested after the loop has completed. So you must do at least one try. Let's say we set it to heads less than 1. So in theory, sometimes it should only take one try. But because it's structured like this, a do while, it must always do it at least once and then check it. There is, as you might imagine, an alternative where you do a check beforehand up here, and then you will not necessarily always even go into the loop. I don't think I can structure this code to do it that way because it wouldn't make sense. So let's do another one. Excuse me. well, the most simple one I can think of is while. Oops, it should be brackets. So the condition is actually going to be similar to the one we did earlier. We're going to read a line of text, and as long as that line of text is not the word quit, what are we going to do? We're going to do nothing, in fact. Just a semicolon on its own, which is usually a bad idea, and quite often will give you a green underline for a warning because there's missing code. But in this case, it's a loop that's going to keep on doing nothing until the condition is true. And luckily, that condition includes some execution that could change the outcome of the condition. So we're just waiting for us to type in quit. Okay, so each time I typed in garbage, it was not equal to quit, and it kept on looping, running empty code. If that's a bit too abstract for you, let's do a more concrete example. Let's have a boolean called game over, and it's going to start off false. That green underline, by the way. Game over is assigned to, but value is never used. That's very common warning. Just you can definitely ignore that one because we've literally just typed it. We can't possibly be using it yet. That is going to go away when we use it. So while it's not game over, you can say, by the way, game over equals false. That's your comparison. Or you could say game over is not true. That's the same thing. Or you could even just put not game over. That does work. That will just take your boolean and swap it. I find some people think that is easier to follow though. So there's your loop condition, and it's tested before you go into the loop. And the body of the loop is going to contain just similar to what we had before. If you type in the word quit, then that boolean game over will become true. So a different structure, a more flexible structure, I think. The loop tests whether it's game over, and if it's not game over, then do something that could make it game over. So it keeps on doing it until you type on quit again. It works. So that is a test before loop. Notice it doesn't contain the word do, because if the do was there, it would just be in there, which wouldn't really be very helpful because it's just the extension of that line there. So we just skip the word do if it's a while do. So there's two types of loops: do while and while do. They are not the only types of loops. There's different languages have different features, but even in C#, there is at least two other types of loops. One of them is based on the idea that quite often you need a counter. So let's show an example with a counter. Let's say you've got a health value of some kind. And we want to show the player how much health they have remaining. And here's the counter I was talking about. We're going to count how many times we have done the loop, hence why it's called loop counter. So this is called the initialization of the loop, because it sets up the initial value of the counter. And then we have the while loop. And it keeps on going as long as that counter is less than some other value, in this case the health. So because 0 is less than 3, so it will go into this loop at least once. But that is still your condition. Let's tidy that up. There we go. And oh, don't forget console.read key so the program doesn't vanish once it's finished execution. So what's our loop body? We're going to just write some weird symbol to the screen. I'm going to use character 167. That's our loop body. So character 167 is just a weird symbol in the ASCII table or Unicode table, which is what we actually use. So we're just going to draw a health symbol every time the loop counter is less than health, which is 3. So effectively that's going to put 3 in there. You can think of that as loop counter is less than 3. So 0 is less than 3, but it's going to stay less than 3. So that loop will go on forever unless we put on some kind of increment. So there's our loop counter. We make it go up by 1, or remember, that can just be loop counter plus plus. So that's our loop increment. Okay, so let's step through that. I'll press F11 and you can see what's happening. So health equals 3. Oh, and by the way, down here, we should have, where is it? Locals. So the local variables you can see in Visual Studio in the locals window, including health and loop counter. It's even got a loop counter, even though we haven't actually got to that line yet. But the compiler knows that's coming, so it's created it for us. So we know that health is equal to 3. And next thing we're going to do is display the words health remaining on the screen. There we go, health remaining. Sets the loop counter to 0. That's that done. While loop counter is less than health, well, the other thing you can do during debug mode is you can inspect variables. You can hover over loop counter and see loop counter has currently got the value 0. Health has currently got the value 3. You can even hover over this operator here, the less than operator. Is loop counter less than health? Yes, that's true. It is. 0 is less than 3. And because that is true, F11 will take us into the loop. And it's going to draw character 167 onto the screen, which is that funny symbol there. I don't actually know what that symbol is. If you know what it is, let me know. But then the loop counter goes up by 1. Loop counter is currently 0. Once that line is executed, it goes up to 1. Notice it turns red in here to let you know the local variables that have changed value. That's the end of the loop. Now, because this is a test before loop, and it's done its test already, it always loops back around to do another test. Loop counter is 1. 1's still less than 3, so it's going to draw another one, go up from 1 to 2, and then reiterate. 2 is still less than 3, draw another one. So far we've drawn 3 health symbols. Loop back around. Loop counter is now 3. Is 3 less than 3? No, because 3 is 3, so it's not less than. It's now false. And because that's the case, it skips over the body and continues with the next line in the sequence. And there you go, we have used a loop to draw a number of symbols onto the screen. What good is that? Well, what if this changes during the game? We don't know when you start off with 3 health, but maybe you get hit by a bad guy and it becomes 2, or maybe you pick up some stuff that gives you a boost and you've got 5 health. The way that loop is structured, it will run 5 times. It runs the number of times that health is set to, because that is the way we've structured our loop counter. Very powerful stuff for later on. Now, but the thing is, this is a test before loop, and it's such a common way to do things, loop counters, that long ago it was recognized it would be really handy if we had a different type of loop just to do that. So that loop is called a for loop. And essentially what it does is it combines this line here, the initialization, this here, the condition, and this here, the loop increment. It combines them into one line, which makes it quite a big line and sometimes. What I'm going to do is leave that code there and put the for loop in alongside it so you can compare. In fact, I can probably, I think I can copy and paste straight in from here, here, although I'll need a semicolon to separate them, and here. It literally is exactly those 3 lines in the for loop. And then the body would be that one there. It doesn't like loop counter because there's already something called loop counter, so let's just get rid of it. I'll comment that out. So that and that are exactly equivalent. In fact, when you click run, it probably would have compiled exactly the same object code for both of these loops. In fact, no, probably about it, they definitely would have, because the compilers are smart these days, they optimize everything. But I mean, whether that's better or this better kind of depends on your point of view. Most programmers would go for this because you get shorter code, and shorter code is typically easier to debug. You could even take the brackets out. You've got 2 lines there now instead of 1, 2, 3, 4, 5, 6 lines. It can be a significant saving. But that's what a for loop is. So let's let's step through that. Same idea. Health is 5. Display health remaining. Loop counter set to 0. Look how it hasn't set the whole line to yellow, just that part there. That's the only part it's executing. Then it checks the condition. 0 is less than 3, 5, sorry, it is now. So draw the character, increment the loop counter from 0 to 1. 1's still less than 5, do it again. 2 is less than 5, 3 is less than 5, 4 is less than 5, 5 is no longer less than 5, so exit the loop. And there we go, for loops in a nutshell. They look intimidating because of the sheer length of that line. Quite often people will just use the letter I here. It's one of the few places where a single letter variable is, I'm not sure acceptable is the word, but it's still often used anyway because it only exists inside those curly brackets. So you won't, the chances of you not understanding what that's for is reduced. Still, single letter variables are generally bad, so we should probably avoid them even here. I did say there's two types of loops that we hadn't seen. Let's look at the other one. It's called a for each loop. So the for each loop looks like this. You put in the word for each and then a condition. Well, actually, come to think of it, in this case, it's not really a condition. What we're doing is an iterator. So the iterator needs to be declared, and in this case, I'm going to make it a character. What you do is you say that iterator is going to keep on going through something in some data in somewhere else. So you put a container in next. What container are we going to look through? Well, what contains lots of characters? A string. So let's put a string in. What's going to happen there is it's going to take the letter H, put that in this variable. In fact, let's expand that name. Next character. So it's going to take the letter H, that goes in this variable here, and it will do something with it. And then it'll move on to the letter E, do something with that, then the letter L, then the next letter L, and then the O. So, and each time it does that, it's going to put a copy of that letter in here. So notice that the original's never changed. Nothing ever changes this string. It just takes a copy of each individual part, puts it in here in the iterator. What do we do with it? It's up to you, but I'm going to make it say what the next letter is. Next letter is, and then that iterator variable comes next, and it will concatenate them. The next letter is H, the next letter is E, and so on. So it's ran that code once for every object in this container on the right hand side. We're going to see more about containers later on, like arrays and lists and so on. Very, very powerful later on. But for now, the string's the only container that you've seen, and we can take the characters out from that. We're almost done with the idea of loops. Two last commands that you can use. Let's take another string, but what I'm going to do is get it from the keyboard, and then for each character in that input string that we got from the keyboard. So we're going to, now it's dynamic. We no longer have the word hello in there. It's whatever you've typed in goes in there, and each character you type in, it's going to do something with it. What's it going to do? Well, if the character you've pressed can use as a space, then we're going to run this line here, break. But if it doesn't break, then we're going to display the next character. What do you think that might do? Well, let's see. Input a string. V General Kenobi. Hello there. It's going to go through each character in the input. Input now contains hello there with a space and an exclamation mark. So it takes the first letter from there. Next character becomes the H. Is the H a space? No, it's not, so it doesn't break. It writes the H onto the screen. H. Next one, E. E is not a space. L. L. O. O is not a space. Write the O. But the next one, after the O, is a space. The ASCII code 32. Is a space equal to a space? Well, of course it is. So now it's true, and it does execute the consequent of the if statement, which is the break command. By the way, see if you have a break command selected, notice it highlights the loop that it's going to break out of. That's what it's going to do. It breaks out of the loop. Even though there are more letters to go, the break command cancels it. So we're left with everything up to but not including the first space. That's one example of how you could break. Break just means come out of the block you're currently in, though. We used it before in a switch statement. It broke out of the switch. This breaks out of a for each. You can also break out of a for, or a do, or a while, and a few other things. And last but by no means least, there's an alternative to break called continue. Let's replace break with continue and see what happens then. Same text. I should have run it in debug mode. You can see it has missed the space. Let's watch that in more detail. Input. Hello there. So there's input is hello there. Take the first character, and that's the H. H is not a space, so it skips the continue. Then we move on to the letter E. E is not a space, that is false, so it skips the continue. L, L, O. Next character is now a space. When it reaches a space character, that condition is true. It does the continue. Now what continue does is it doesn't break out of the loop, but it does skip one iteration of the loop, so it doesn't write the next line. It goes straight to the curly bracket and back to the start of the loop. So break stops the loop entirely, continue skips one iteration of the loop, otherwise it's going to continue through the loop until the end. So there we have it. That's iteration, the basics. It's got do loops, while loops, for each loops, break, and the continue command. And that's enough for now.